Hey guys, welcome back. Chapter 14 again, looking at sections 3 and 4 today, okay? So follow along and take notes as we go. Alright, so we talked about the atmosphere last class, and all that air that's above us actually has a lot of physical properties to it, okay? So air has mass, which means there's weight to it. You can actually feel it, okay? Because of that, it also has density. We talked about how the atmosphere is more dense close to the surface, and then it gets less dense as we get away from the surface. We'll talk about that more. But it also has pressure. That mass is actually pushing down on us, okay? And that air pressure is felt all around us, okay? If you think of like putting yourself in a 1 meter box, okay? So just drawing a 1 meter square around you. And now imagine all the air above you, all the way to the end of the atmosphere. The mass of that air is close to a ton. It's close to 2,000 pounds. And so I guess my question is, why doesn't it crush us? Why aren't we just smashed down? If something that weighed a ton landed on you, you'd be toast. But the air above us doesn't do that, okay? Think about that, and I'll come back to that. A barometer is an instrument that we use to measure the air pressure, and it's actually a really good predictor of weather patterns. As the air pressure changes, meteorologists, weather people, use that as a way to predict the changes in weather, okay? The amount of air above you actually changes with your altitude, okay? So if you're at ocean, at sea level, you have the most air above you, you have the most atmosphere above you. But as you go up mountains, you have a little bit less atmosphere above you, okay? And we're going to talk about that on the next slide. Actually, let me go back really quick and kind of address that concept of why the air doesn't crush us. Well, it is true that if we measure all of the air above us, it would weigh about 2,000 pounds, roughly. But it's not just pushing down on us. The air pressure is pushing all around us. It's pushing on the sides. If we hold our hand out, it's pushing up as much as it's pushing down. And our bodies are designed to be used to it. But I'm going to show you some demonstrations. I'm going to have a demo video in addition to this lecture video that will show some different air pressure concepts that I definitely want you to watch. And it'll kind of explain that concept of the mass and how it pushes all over, okay? All right, so now let's relate air pressure and altitude, okay? And we've got our little Eskimo up here, up in the mountains, all right? Here he is, right up there. And you can see, well, there's another one down here. You can see that the dude down on the bottom of the mountain has a much taller air column above him than the guy on top of the mountain. His little air column is not as tall, okay? So because of that, again, most of the air is above you at sea level, and that's where the highest air pressure is. There's some relationships between this. As your altitude increases, there's less air above you, and so there's less air pressure, okay? So as altitude increases, air pressure decreases. As air pressure decreases, the density also decreases, and you can see this, okay? The air down here is much more tightly packed, okay? It's much more dense. Up here, it's much more spread out, okay? And so the way the atmosphere works, we talked about the fact that it doesn't have like a border, it doesn't have just an edge. Well, eventually those air particles get so thin, so far spread out that there's practically nothing, okay? There's not a clear edge to the atmosphere, though. So as you go higher, as you get farther away from the surface, it's less dense. And then this concept of higher pressure always going to lower pressure is important. And it'll come up time and time again. We talked about it a little bit when we talked about those sea breezes and the land breezes. We'll talk about it again in a later chapter when we talk about winds. But this is why your ears pop. When you're driving up into the mountains or even coming home from the mountains, this is why your ears pop, okay? So if you're at the bottom of the mountain, there's some air inside of your ears too. The air pressure inside of your ears is equal to the air pressure outside of your ears. It's stabilized, it's normal. But as you're going up the mountain, remember, as altitude increases, air pressure decreases. So now outside of your ear, there's a lot less air pressure. Well, high inside wants to get to low outside, and so your ears pop, okay? And that stabilizes the pressure. Has to reverse the process as you come back down the mountain. So if you've ever seen a water bottle, if you've driven down the mountain, it looks collapsed. And the reason for that is when you closed up that water bottle up in the mountains, it had its pressure. It was a lower pressure compared to down the mountain, but it was stable up top of the mountain. As you drive down, the outside pressure is getting higher and higher and higher, and so it wants to get into that lower pressure, and so it actually causes that bottle to collapse. You might have seen this with chip bags, okay? If you buy a bunch of chips down at home, and then you drive up the mountain, the chips are used to the pressure where you bought them, okay? But as you're going up the mountain, as the altitude is increasing, remember the air pressure is decreasing, so the pressure inside of that chip bag is higher than the outside, and it wants to get out. It wants to go to the lower pressure. And so those chip bags get really plump, okay? And they're easy to pop. Sometimes they actually do pop because the air pressure wants to get out so much, okay? So definitely understand those the relationships between altitude and air pressure. All right, now let's get into the actual atmosphere again itself. The atmosphere is separated into multiple layers, okay? Let me just go ahead and bring all of these up. Now, there's some debate on whether there's 4 or 5 layers, okay? The book talks about 4 layers. It actually talks about these 4 layers right here, but it talks about how the thermosphere is divided into these 2 layers. Some scientists count this as its own layer, okay? And this diagram that I have here counts the exosphere as its own layer. It doesn't really matter, okay? I am going to test you on all these different layers though, so make sure you understand them, okay? All right, so starting at the surface, we've got the troposphere. That's the lowest layer. It's what we kind of really think of as the sky. That's where the clouds are, and that's where weather occurs, okay? And it is roughly 10 kilometers up. Now, for every 10 kilometers, that's about 6 miles, okay? So just kind of keep that transition in mind. From the troposphere, we go to the stratosphere. That's where the ozone layer is, and the ozone layer is really important. It absorbs all the ultraviolet radiation from the sun. That's what, well, not all of it, but a lot of it. That's what gives us sunburns and can cause skin cancer. Sunscreen also does that, but without the ozone layer, it would be happening like to a crazy extent. So the ozone layer actually protects us a lot. And then that's also where commercial jets actually fly, kind of the lower part of the stratosphere. They go up pretty high because it's less turbulent up there. Because the air is so much less dense. Then we go to the mesosphere, and that's where meteors burn up. As they hit that part of the atmosphere, it's starting to get a little more dense, and so there's a lot of friction, and so those meteors actually burn up, and we see those as shooting stars, okay? Finally, we get to the thermosphere, kind of the top layer, and eventually that just blends with space, okay? There's no like line, and actually it changes, okay? Depending on the temperature and density of the atmosphere. It could actually be kind of a ripply edge, if you will. But as the air particles are getting more and more spread out, they eventually just aren't there, and then we're in space, okay? The thermosphere, for our purposes, is broken up between the ionosphere and the exosphere, okay? The ionosphere is weird. There's crazy stuff that happens there. Radio waves kind of get stuck there and they bounce back to us. That's how like a lot of the radio signals we listen to, they kind of go up there and bounce back. That's also where the northern lights and the southern lights are happening. That's a lecture all in itself, okay? But basically what you're seeing is ionized gases. The gases are getting excited and they're becoming charged and they start to glow. Super simple explanation. It's way more complicated than that. And that happens way up in the ionosphere. Then past that is the exosphere. And like I said, that's the super ultimate edge, and there's actually satellites that orbit there. Some orbit down a little bit closer in the thermosphere itself. Some are much farther out, but most of the satellites are actually out in that exosphere layer. Okay? Pay attention to how the temperature changes as well. I'm not going to test you on that at all. I just think it's interesting how it kind of goes up and down. There's a lot of complicated explanations for why that is, and I'm not going to get into that. But if it's something you're curious about, definitely spend some time looking that up more. Okay? I think that's all for today. It is. All right. Have a good afternoon, guys. Bye.